Jeff while we've got him.
And we could keep asking him.
Yeah.
We're exactly on time. It's okay.
Yeah. So.
You're fine.
Okay, thank you. So I've been asked to run this in sort of very removed geographic thing.
We asked him to ask difficult questions. Put us on the spot.
So yes, well, this is your chance now to pod them and get their opinions and find out what direction and background you know. So I'll kick things off. So I'll start with sort of general features and various things and some directions. Oh, sorry. Yeah. Do you want to sort of quickly?
Yeah. So I'm Stefan Karpinski. I'm one of the people who originally started this thing. I went to grad school with Viral, and we got talking about dissatisfaction with the existing programming languages for doing numerical computing. He told me I needed to talk to Jeff and Alan, and things started.
Jameson Nash. Go by ETJ Nash on GitHub. I got started just as they were starting to open source the Julia project, and I heard about it from a class that I was taking. Jeff was the TA. We started working on some low-level bugs and got hooked.
Was that 8337?
Yeah.
That was 8337?
Yes.
MIT speech.
Yes. All right. I'm Keno. I've been working on Julia since early 2012, about March or so, when it was announced on the internet. Probably one of the first core developers outside of MIT to start working on it. I guess early on I did the Windows port because back then I was on Windows, and that was merged January 2013. Since then I haven't been on Windows again. So thanks a lot to Jameson for basically picking it up mostly from there and making sure that Windows stays at least halfway functional. Yeah, since then I've been doing like a lot of low-level code gen stuff. And recently, probably, let's see. Oh yeah, I worked on the REPL, the new one. So the new REPL, I wrote that low-level stuff mostly.
You're going to give a talk on the debugger.
I'm going to give a talk about it. Yeah, that's actually good that we're doing this, because then I can like not take away time from my talk to introduce myself. Because 30 minutes is not a lot of time. Kind of stuff.
Hi guys, I'm Viral, and Stefan already talked about how we got together, so I'll just not say anything more than that.
I'm Jeff. So Viral could say a whole lot more, even though he's not choosing to do so. So maybe I should. So I'm Alan Edelman. I'm a professor at MIT. I'd like to say that I was the first student in the history of the world to use commercial MATLAB, and I know that because my advisor bought the first license. So I've been using it for a long time, and 6 months ago I went cold turkey. I don't use MATLAB anymore. Except unless I have to run some old things. We had at first an academic and then a company doing a parallel MATLAB type project called StarP, and Viral was there during the early days of the academic project, and then Jeff joined the company, and it was pretty clear that Jeff was pretty brilliant. And we knew that this parallel MATLAB thing needed something completely more and different somehow, and somehow Julia came, from my point of view anyway, Julia came out of all of that.
Right. Very good. So I guess we'll start on some of the features and so various things. So I guess that kicks off one thing that has become huge for the last few years recently has been GPU.
Can you speak up?
Yeah, so GPUs have become very popular, especially, and have now been applied to very few problems. So when we've got some experience like deep learning type things, so libraries like Keno and Torch made it somewhat easier to use these things. Is this going to make you do this?
I mean, so I guess there's two approaches you can take to GPUs. One is basically what we can do right now, which is you have basically all your kernels pre-written in C or something, or whatever kernel language you have for GPUs, and then use some Julia package just to do the high-level dispatching of kernels and moving data between the GPU and main memory and that kind of thing. And I haven't used it myself, but as far as I understand it, a lot of that is actually working. A classmate of mine actually surprisingly came up to me and was like, "I've been using CUDA with Julia and like sped up my problem." I was like, "Okay, I didn't know we could do that. That's cool." I mean, there's a different thing which we might be able to do with Julia, which is since we are based on LLVM and since a lot of the GPU compilers nowadays are based on LLVM, we might be able to like write GPU kernels in Julia. But I think we have quite a way to go on that, and actually some of the type system reorganization that Jeff was talking about might go a long way, just because tuples and everything would actually be better represented in LLVM. So if you use tuples, you might be able to actually get the GPU vectorization. But that obviously isn't implemented yet, and it'll probably be quite some time before we can efficiently do that. But it's definitely possible.
So there's actually a third approach that I prefer, which is to hope that GPUs go away.
Would it be good enough if they sort of morph into something else?
Possibly, yes.
Yeah. So that's, I mean, the Xeon Phi is sort of an Intel answer to GPU computing. It's sort of maybe between a normal CPU and a GPU. So that might, to me, one of the big problems with, there's two major problems with GPU. One, it's like not a very general purpose thing to write code for, so you can't take an arbitrary program and execute it on a GPU. You just can't. So something will work, something won't. And it's, you know, I want to be able to write all of the programs, not just some of them. And then the other issue is that if you look at the Julia GPU organization, it's got, you know, 6 different packages or something like that. I want one package. I just want it to work with whatever GPU I've got. And actually, the thing that Pontus was talking about yesterday, what is it, OCCP or something? What is it? ACA, OCCA or whatever. Looks promising. I mean, that could let you, you know, instead of having to write code that's specific to every single vendor's GPU, you could maybe use something higher level and abstract like that. And that makes the whole thing more viable to me.
Well, such a technology exists, it's just called OpenCL, right? No one uses it.
But you know, I mean, so some of the immediate stuff like you know, just CUDA and all that. I mean, we could probably be doing a better job just packaging it up or making it easier to use with Julia. But you know, that's probably like so that your CU FFTs and CU BLAs and all that stuff are easily accessible.
I mean, that's largely already true. I mean, I guess the CU BLAs is not, to my knowledge, but FFTs work.
They work just fine.
Yeah.
Yeah, what we're missing is like a GPU array type, where you can, you know, share an array description across CUDA or across. Then interoperability would be much better, because right now you basically have to just give it a flat buffer, like you wouldn't see, so you gain no abstraction.
The big problem with doing a big array type like that, though, is minimizing the data transfer over the PCI bus.
So that was, I mean, that was exactly the second point I was going to come to is the programming model. I mean, you know, it's easy to hook up all these things. You can even get the code gen maybe with a lot of work, but how does the programmer work across all these memory hierarchies? And it's not fun and it's not easy, and you know, I mean, where do you draw the line?
Well, that's getting better actually. The next generation, I mean, that's just starting, where they're starting to, you know, try to abstract that away, and it's going to get better over time. So I think at some point, just like everything else, you won't, if in the more normal cases, you won't actually have to worry about that. It'll just handle it automatically for you, and it'll be good enough. I mean, you always will be able to go and explicitly do it to gain the extra boost in performance. But I think the next generation will see that that's going to drastically improve.
I might change the topic. Any other more questions from the floor onto features or various things that you think Julia should focus on? Done.
So I know you talked about the idea of having a string rewrites and thinking about that. And certainly I think the thing that I find most frustrating to interact with is in the type system is strings. And especially because there's lots of C code one might want to use, like stemmers, that assume that everything's totally mutable, and wisely so, because a stemmer never needs things to get longer, they're always going to get shorter. And so to what extent are we going to have sort of a better version of strings that's like something at least allows some sort of admitting that from underneath the hood is mutable? Because right now, basically, I certainly have done lots of hacking where you just look at the data, mutate the data, and just pretend that nothing's happening. But
I'd start by saying that the mutable string type we have right now is IO buffer.
okay.
So technically, if you want to mutate your string, you should declare it as an IO buffer, and then it's a mutable string.
Well, that doesn't really support random access kinds of mutation, though.
No, because it's a file access, so
Yeah,
you're not
it's a file-based
supposed to like directly index it. We could add that, I guess.
But also, like
But
UTF-8
it's-
does not really play very well with mutation. So because if a character changes size, then you can't do anything efficient. So
Well, lots of these codes don't work very well if you're not looking at English to begin with. So.
fair point.
Well, I mean, just like, like one example, like almost no one in the world knows how to do natural language processing, to my knowledge, with Arabic well. So like, many languages just sort of like, we just say like, we give up on this. And then, certainly I'm very focused on English is the thing I would work with.
So it's an interesting, the thing that's interesting about that question, I've spent a lot of time thinking about and talking about the string rewrite, because I think right now our strings are, they're kind of a performance disaster. They're not that bad because we sort of have a bad design for the string subsystem, but the language is fast enough to kind of compensate for it, so we end up sort of like at a wash with a lot of other high-level languages. But having the array, every string is an object, and then it has an array, and the array has all of this overhead. It has like 60 bytes of overhead, and you've got to allocate. It's the fact that you want to represent a one-character string and you have this like huge amount of nonsense is just it's unacceptable. It's like not good. But mutability is not something I had thought about. I actually wanted to go the other way and like really leverage the immutability more. If you're going to have immutability, get something for it.
So I don't necessarily want, I would not advocate a mutable string type, but it would be nice to sort of have something like bytes of S, where you say like, I now want to treat this just as bytes and ignore the fact that it has string-like properties, and then sort of easily go back and forth. And I've played, hacks with like UTF-8 string to do this and things like that, to try to go back and forth, but at least to me seems nicer to have a sort of easier transition between mutable and immutable string.
Right.
So you basically want to like string wrapper around like basically what we have now with the string wrapping an array, but mutable.
Or just just acknowledge that the string's wrapping an array and not like right now. I'm looking at like .data often, just modifying .data. It seems like a cleaner story than that is what would be desired.
Right. I might switch now to sort of a more overview of the project in general. So I'll start with perhaps a controversial one. Alan, what happens when the grant money runs out?
We have grant money?
How does this sort of, now that everyone is working on seems to be sort of employees and students at MIT, vast majority, so what?
I got the sense that most of the work was happening around the world.
Yes.
This was a small piece of it.
I guess as the core team, particularly as working the core, Julia, is that going to be maintainable with that?
Well, this conference is a good experiment. We can see what happens when all of us stop working on it for a couple of days. It'll be more of that. No.
There's still people out there.
There's still quite a lot of stuff happening. I'm behind now. But I'm in this for the long haul. I'm just going to keep doing it. I'm not planning to stop.
And I'll keep writing grant proposals.
I'm used to instant ramen, so I won't notice.
Yeah, I think
is this the core team or what's the core team?
It's unclear what that is.
We just had a little bit of difficulty figuring out who was supposed to be on this panel. So we don't really know. It's not very clearly defined.
This is sort of the people who are most likely to break your programs based on.
But I don't think we want anyone to feel that there's some sort of elite core team and like there's a club that you can't be part of or something.
Well, perhaps it's people who understand intrinsic stuff.
I think we've reached the point where getting funding is not. It's never super easy, but more people hear about something, the more likely it is that you're going to write a proposal and you'll be like, oh yeah, I've heard of that thing, and give you some money. We're planning, so we also have the Julia Computing LLC, which is, funding part of this, the conference. So we make some money off of doing commercial consulting and support kind of things. So that'll help in the future. I could probably at this point live on just that and not the MIT stuff. So I'm also in the same boat where I'm going to keep doing this no matter what.
Yeah, I think that applies to pretty much everyone.
Well, my dream is to hire Jameson from his full-time job. We have to have enough money so we can pay him to just hack on Julia stuff.
Yeah, would anybody guess, looking at the commit log, that Julia is not Jameson's full-time job? I can't believe that.
Well, if anyone's writing a grant proposal that can have Julia in it, do let us know.
Can I list all of you as recommended reviewers?
I think one of my PhD advisor is doing that.
Are there any other
One of the
questions?
students.
Other questions on sort of the structure of Julia?
We've heard a lot of, occasionally yesterday about the loops that are so costly in R, and it's great, they're fast in Julia, and that's fine. But I personally like the more functional approach to programming, but I don't want to be boxed in necessarily always functional. So I'm fine with loops, but in small quantities. So what's the and I think right now the anonymous functions are slow, right?
Yes. Yeah.
Any plans on improving this and getting more functionality from the functional side?
Yeah, we're not very good at functional style of programming. It's only possible, but not fast. There are going to be some improvements there. There's a lot of room for improvement, so that's a good thing.
Okay.
Jeff, isn't one of the applications of this type sort of revamp that you're thinking of the idea that we will be able to lift values into the type inference system?
Yes.
Which means it'll make it more possible to specialize functions on values.
Yes.
So among other things, that allows you to specialize on the actual value of a function argument, at which point you can actually inline a function that you passed to the sort function, right? So you have your own custom comparison that you want to use for sorting, and then it can just actually get inlined.
Yeah, I mean, there are a lot more optimizations we can do, but our model of things is sort of a mismatch with the typical function types like you find in most functional languages, because there isn't a really solid notion of what the return type of a function is. First, because of the large number of definitions, and then even within a single definition, we might not be able to infer exactly what it returns. So it doesn't match very well with your typical kind of arrow types. It almost, in some way, it almost sort of has the exact opposite properties of a sort of functional language in a kind of very loose way.
Is there a reason? Is there like a fundamental reason why annotating return types of functions isn't a good idea?
No, that can be done.
Yeah.
Yeah, you can clearly do it in at least some easy cases. Yeah.
I was actually just about to ask you about that. I kind of had my fingers burned a while ago. A function, if something happened, it returned to 2 tuple. If something else happened, it returned to 3 tuple. So my code would break in some cases and not in others, and I had a hard time figuring that out. Is there anything? Are you have any plans to make a more consistent return type, definable as a programming interface?
So Leah has been working on some tools to make it easier to find things like that, I think. So that might be able to help. Typecheck.jl might help with things like that. But I think we'll also add just the ability to declare a return type. That's a feature that's been a long time coming.
Okay.
One open question about the return type declaration is, should it automatically convert, or should it just assert that your return value is of this type and throw an error if it's not?
Probably convert, but I guess that's not 100% decided.
Well, one question sort of on not a specific feature issue, but on a just more general sort of development philosophy style. There are periods, for instance, I suspect we may go into one soon where once 0.3 is out, 0.4 floodgates open, and a whole bunch of separate patches, that do pretty radically deep things, get merged. So, what's the view of the balance between the speed of merging certain things and the the desire to shake the bugs out of one sort of, major functionality before merging in the next one, right? I mean, in other words, if you merge 3 big pieces of functionality, all within the same week, does that make it substantially harder to sort of figure out what the culprit is, really, or is Git bisect such a good tool that that's nothing we really have to worry about?
I think I'm in favor of opening the floodgates and putting all of the big breaking changes in at once, and then just allowing maximum time for them to stabilize.
Okay.
Yeah, chaos
I think
mode.
that's fine with
It's time
me.
for chaos mode.
We haven't had one of those in a while.
It's been a while.
Yeah.
It's been a
This
year.
is
though.
before
Because a lot of stuff
0.1.
is being held for 0.3 to come out.
Yeah.
So I've already told a couple of people, perhaps inappropriately, that there were goals to have a 0.3 release candidate on Saturday as part of Hack Day, but I think that's reasonable, right?
I've been saying that too.
I've been spreading that around as well.
I think that you follow the language releases, we've started to become fairly consistent that any large request that comes in more than a month or 2 after the last candidate just gets held up, and we leave it in the Git pull queue and say when the next release comes out, it'll merge within a month of that. So if you want a relatively stable language, stay on the stable language for at least a month, and then you can switch back. And then even the stability of our unstable changes based on the availability of a stable release.
I mean, one of the things I feel like we have not, there's a bunch of pull requests that I wish we had merged, that we didn't merge because we thought we were going to get a release out sooner. Although I always thought that was kind of naive. I didn't really think that the 3-month turnaround for a new version was realistic. But we could have had array views by now. We could have had.
Yes.
Just a note, Saturday, which was mentioned, is tomorrow.
Yeah, tomorrow.
Yeah.
Oh, I didn't realize that. Oh, that's.
Yeah. Well, there's only, I think, 13 issues open, and a bunch of them are upstream. I think we should just, say this is a release candidate and wait for upstream bugs to get fixed. That's a reasonable strategy.
Can you talk a little bit about GC improvements?
Yeah, so there's that great patch that Oscar put up several months ago there's a lot of great improvements to the GC. I'm really hoping to merge those for 0.4. He has a list of sort of the remaining things that need to be done, but when those are done, I think it's going to go in.
Cool. That would be great.
Yeah.
Can I just see what it achieves?
The GC is definitely one of our major bottlenecks for code that does a lot of allocation, which is pretty common. And so he did basically 2 things, I think. So first he did an incremental version of the GC, so you can limit the pause time. It'll just collect in 5 millisecond increments at a time. So that was the first thing he did. And I think he also did a further improvement, which basically it goes by several names. I tend to call it single bit ref count, which basically means you tag values with a single bit if there's a reference to them from the heap, and that lets you very quickly separate which values are only referenced from the stack and therefore probably ephemeral, and then you can collect those much more quickly. So it should get a lot better.
Is the 5 milliseconds like a hard max? Like it will stop garbage collecting at 5 milliseconds?
Yes.
Any?
Okay, but
So we're going to have a section on graphics later on today, but so if you want to defer any discussion on graphics until then, that's great. But I think that a lot of the big things, there are clearly core language improvements that we want, but certainly environment is a major thing, I think, for making it even more friendly. And the work that Keno's doing on the debugger is a major part of that. But so you guys decide, do you want to talk about graphics in terms of, say, bundling, Julia with a single chosen graphics toolkit or not? Is that ever something we actually want to do? Or?
I think we all want to do that, but we can't nobody agrees on what graphics toolkit is the one. But
Yeah, I think my first priority is the poor, neglected base graphics.jl file, which was supposed to be something like kind of compelling, but it just is completely stalled. And that needs to be resurrected. and at least have some good base types that everybody can share for talking about graphics-related things.
Yeah, hopefully later we can talk about what functionality all the graphics packages need and have in
Yes.
common, and then like sit down and actually all pull it out into these graphics.
Yes, that would be a great thing to do.
But then there's the other thing with the windowing toolkits. I mean, you know, we go with GDK, or is it TK, or is it something else?
The GTK is kind of looking like
It
the
is
best
looking,
option
yeah.
right now,
Yeah.
yes.
Yeah,
On it now?
we had a talk about that yesterday and kind of the issues that we've seen. And one of the things that is problematic if we want to try to bundle any GUI toolkit is the dependency how what we were seeing like on Keno's machine, he wanted a private copy of Cairo for some reason, and it pulls in parts of the dependencies for GTK. And so he ended up with 2 copies trying to load in Julia. And some libraries would call into one library, and some functions would call into the other library, but you need them to interact. So this is the reason MacPorts and Homebrew put up this big warning banner when you try to install them together, that if you ever have 2 copies of the library, it just doesn't know which one might get loaded. And it's okay only if you only ever load one of them. Mac tries to help you a little bit because any library is then tagged with which one it got compiled with the absolute path. But that ends up almost hurting us if you want to try to have multiple copies, because it got tagged with exactly which one that library wants, and the other library got tagged with exactly which one it wants, and then Julia tries to pull in both, and they can't share.
But that's only a Mac issue, right? Does that mean it works really well on Windows and Linux, or?
The situation just is different on those platforms. Linux has one package manager usually per operating system, and you use that one, or you compile your own packages against that one. You don't usually run into the situation where you would have multiple independent installations of binaries. Windows is pretty much the same way. It just doesn't have a package manager, so nobody has packages on there, and you don't run into the issue because just nobody has them. You have to give them a private copy that has been custom compiled.
I mean, what about, can we just simply distribute a Julia version of GTK that comes with, with Julia itself, basically, right?
Right, so you could do that, but then if you wanted to add any other packages to it, so GTK is one library built on top of glib, but there's hundreds of others that let you do different things, different file plugins, different widgets that you might want to view, different things that are really nice to have but aren't included in the core GTK. And then you'd either have to be in the business of distributing all of those custom compiled to only link against your libraries, or you'd have to tell someone that as soon as they want to do anything extra, they need to delete the one that Julia provided so that they don't load 2 copies, and then go get the other one. So the recommendation I put on the page is just go get MacPorts and download it. Then you have everything, but it is like a 2 GB download because you have to start with installing Xcode.
One approach might be to have a smarter dynamic library loader in Julia, like just kind of roll our own that kind of knows about that. It sounds kind of crazy, but we have all the, thanks we have all the parsing code to actually parse all the shared libraries. And on Linux, we actually almost do something like that because we actually parse lgconfig output to see like which alias for the library is the correct one. So we might try to be more fancy with that and maybe avoid some of those issues.
Dan, you got a quick question?
This is issue 550, so it's been around a while. We don't have control flow in comprehensions, and I'm not exactly sure what the holdup is. It has something to do with trees arrays.
Like guards and conditions?
Yeah.
Oh, okay. Let me see. So yeah, that I think that could be added pretty straightforwardly.
So the main issue there is what it should mean. In the one-dimensional case, it's pretty straightforward.
Yeah.
In the multi-dimensional case, you can't. You can't do. So if you're trying to generate a matrix and you have a condition that eliminates, random points in the middle of the matrix, what does it mean? What does that thing produce?
Yeah.
So
there's an easy version for 1D that could be implemented, certainly.
Yeah. So we could only allow it for 1D.
Just do it for 1D for now.
Yeah. For 2D, you could either say it has to just eliminate an entire column or an entire row.
Right.
But then you'd have to consider how do you enforce that?
Well, should we implement it tomorrow?
Also,
After stage 5.
are they slower than regular comprehensions? Are they slower than if you just wanted to do a regular loop? Or-
Yes, I think so. It's pretty crucial to know the length of the thing beforehand.
Okay.
Anything where you don't know what the size of it's going to be in advance is pretty much going to be slower.
And why does it lose its type information?
When?
Why does it lose its? It always returns any, I think, doesn't it?
That's one of the things, right?
What does?
Comprehensions, they used to, but no longer, I thought.
If you do a comprehension, it'll-
Comprehensions are the only thing in the language that is currently really dependent on the ability of type inference. So if you use comprehensions at global scope a lot, where some of your variables are global variables, like type inference will give up and return any. But usually, if you have comprehensions in inner scope, you'll get the tightest type. And we've actually been talking about changing that. Or Jeff has been
Yes,
talking about
I think we're going to change that.
changing that so that the comprehensions will always give you the lowest common type of all the elements that are
Yeah.
generated.
Okay, might have to wrap it up there then. Could we please thank all the do pester them a tea.
Yeah.